Okay, so we are doing problem 1 of midterm from final of 2014, and the problem asks, it's right here. So, 254 milligrams of methylene was reacted with 262 milligrams of oxygen gas in a sealed 22-liter flask, and the reaction proceeds to completion. So we're not dealing with any equilibrium here. It's just a single direction reaction. So the first question asks us to balance it. So here we go, balancing it. We know that the formula is given right there. And we have oxygen gas, so O2. And in a typical chemical reaction, when we're adding oxygen gas, it's probably going to be a combustion reaction. So we're going to have CO2, H2O, and in this case we also have nitrogen gas, so N2. Okay, now to balance it. So we need to decide which one's the most complicated of these equations that we need to balance. So it's probably going to be this one and this one right here. So, sorry, there's supposed to be a 2 here. So we have 5 H's in here, that's the most common one, and we have 2 over here. So we can start off with putting a 5 here and putting a 2 here. Now they each have 10. Okay? Now to balance the O's, we have 2 here and 5 here, and we only have an O2 over here. So we know that we have to multiply these two factors by a factor of 2 because we have an odd number here. So let's do that. 10, 4. Now we have 10O, 12. Now we have 12 O's over here, and we need 12 on the other side. So multiplied by 6. Alright, now for carbon, now for nitrogen, we have 4 times 2, 4 times 1, so we put a 2 here. And for carbon, we have 4 over here, so we need to have 4 over here. And this changes the number of oxygen. So now we have 10, 18 oxygen, so let's change this to 9. Now we have 18. Now we should be balanced. Put that the gases, label the gas, and 4 CO2 gas, 10 H2O gas, 2 N2 gas. Alright, so now we have a balanced equation. Now for the next part of the problem, which one is the limiting reactant? Okay, so basically, in order to determine the limiting reactant, we need to use the values that are given to us for the milligrams, which, as we recall, are right there. So let's change it to moles, because in order to deal with these reactions, we need to deal in moles, not milligrams. So I'm just going to change it to grams in the first place as well. So we have this many grams of CH3 and H2, and we multiply this by the molar mass, which I previously calculated, 34.012 grams per 1 mole of this compound. And now we need to compare it to something, say, on the other side of this equation. And I believe the easiest one to compare it to is 2 and 2. So in order to, we need to do the coefficient, molar ratio, excuse me. So we have 2 mole of N2 divided by 4 mole of CH3 and H2. And I'm getting this from these coefficients here. So grams cancel out, moles of CH3 and H2 cancel out. So now we're left with moles of NH2. So when we multiply it all out, we get that it comes to be this number. And we're keeping a lot of digits right now until the end, so we're not getting any rounding errors. So that's how much N2 gas can be produced if we're using methylamine for the reaction. Now let's solve it for oxygen to see if that's the limiting reactant. So let's go to oxygen. 262 grams oxygen. So that's 32 grams per mole. And we can multiply that by the molar ratio, which is 2/9. 2 mole N2, 9 mole O2. And again, when we cancel this all out, grams O2, moles O2, we have moles of N2 left over. And that comes to be, let's see, 0.0018194 mole N2. Alright, now we need to get a little intuitive over here. So now we need to consider when we use methylamine gas, we are able to produce this many moles of N2. When we use oxygen gas, we're able to produce this many moles of N2. So we notice that we're able to produce less N2 by using oxygen. Therefore, this oxygen is our limiting reactant. And that's the maximum amount of N2 we can produce, because a reaction is always limited to the limiting reactant. So we can identify oxygen as a limiting reactant that way. Next question asks us, how many molecules of water are produced? So now we can use the amount of, let's see here. Now we can use the amount of N2 that we found out we can produce and compare that to H2O, because we know this is a molar ratio that we need to satisfy this equation. So this many moles of N2 is the maximum number of moles of N2 that can be produced. So if we use this in the molar ratio, we're able to see how many moles of H2O can be produced. So mole N2, and we multiply that by the molar ratio. So as we recall, we have 10 moles of H2O and 2 moles of N2. So we want what we want on the top, 10 mole H2O, and what we have on the bottom. Okay, so this obviously cancels out. And the question asks molecules of H2O, so we're going to multiply by Avogadro's number. So per mole, we always have 6.02214 times 10 to the 23rd molecules. And we get, when we calculate this out, is 5.48 times 10 to the 21 molecules H2O. So that's our answer over there. Now, the last question. What is the concentration of nitrogen gas in the flask? Okay, now we already have, so let's recall what concentration even means. Concentration can be defined as moles per liter, and we use that for molarity. So we have the moles of N2 right here. We already did that. And if we look back at the original question, we have 22-liter flask. So let's put 22 liters. And when we divide that, we get that it is this molarity. And that's the answer to the last question of problem 1 in 2004 final. I hope that helped. I know it's been a while since we did these types of problems, so I thought a good refresher of these might help for the final coming up next week. Bye-bye.